And we're back, this time with Matthew. Matt, are you with us?
Hey, yeah, I'm here.
Good to see you. We have a whole packed day ahead of us, so I'm just gonna have you take the stage.
Let's see if I can squeeze this into 10 minutes. So, um, so I'm going to talk about ADBC and how it's, what makes it better than ODBC and what, you can do with it. So, first things first, who am I? I'm going to blaze through this. I am the author of In Memory Analytics with Apache Arrow, a PMC member on the Apache Arrow project, and a committer in Iceberg. So, quick primer on what Apache Arrow is, in case you're not familiar with it. It is an in-memory column-oriented data format. It's a spec. There's implementations in a whole mess of languages. Go, C++, Rust, Python, you name it. The entire point of it is, aside from being super performant by being column-oriented in memory, it's also the exact same layout in memory as it is on the wire. So you get to avoid all of those serialization and deserialization costs. You can pass data from your systems and between nodes and machines without having to serialize and deserialize. You can just pass the raw bytes through. And if you're not familiar with the term columnar, which I hope everybody is by now, but if you're not familiar with it, it's just a matter of how you orient and how you store the data in memory. If you have your table of data and you have your buffer of memory, your traditional row-oriented buffer is going to be, column 1, column 2, column 3, column 1, column 2, column 3, in order that way. Whereas if you are doing it in a column-oriented way, you end up with all the data for a single column in a contiguous chunk of memory. This is important because it improves your I/O performance. That's why, say, Parquet is column-oriented. And it also allows you to only read or allocate memory for the bits, for the columns that you actually need to operate on and utilize. It also means that your data is already in a configuration that is ideal for vectorized processing and vectorized SIMD. So now that we've sped through what Apache Arrow is, let's actually talk about what I'm here to talk about there. And the most common way people interact with databases nowadays is still, unfortunately, JDBC and ODBC. In your typical case, you have your application. You send your SQL query to the ODBC or JDBC API. You have loaded a driver of some kind, so that driver implements the database-specific network protocol, sends the query to the database, retrieves the results from the database, converts that data into the format for ODBC and JDBC, and finally returns those results through the ODBC and JDBC API. And one drawback there is the fact that if your database and your system is column-oriented, now you're forcing it to do a whole conversion from transposition of rows to columns and columns to rows just to pass your data through. So, people use it because, ODBC and JDBC aren't going anywhere. It's been around for decades. It's going to keep going around. And if you're dealing with your standard traditional transactional use cases, it does what you need. But nearly all analytical database systems nowadays are column-oriented for all the reasons I mentioned earlier. Improved I/O, SIMD, vectorization, and just when it comes to analytic processing, column-oriented is the way to go. Which means that if you're using ODBC and JDBC, you now have to do a conversion just to pass the data over. And a conversion is also a copy, which is expensive and slow. If you want to avoid that conversion, then you need to have specific SDK integrations with each and every system you want to integrate with. And that just is complex. And look at all the connectors that Trino and others have to implement just to be performant. And so there's another way. That's entirely the point of what I'm talking about here. So ADBC, Arrow Database Connectivity. It is a similar concept to ODBC. You have a single API that your application interfaces with, and swappable drivers. The big difference is that the data being passed through is all arrow-based. It's column-oriented the whole way through, so that your column-oriented data doesn't need to get transposed. So if we look at that diagram earlier, you can see that you send the query to the API just like you did before. You loaded an ADBC driver, so it sends it to the driver, and the driver talks to the database. Now, if the data system returns data as Arrow already, there's no conversion, there's no copy. Just pass it right through. In fact, at the API level, you're just passing pointers to the raw buffers, because the data that comes back as Arrow is already the exact same layout in memory the way you want it to be, because that's what Arrow is good for, that interoperable transposition. If the data system does not support column-oriented Arrow data, then the driver does the conversion to Arrow, which means that your application side only ever has to deal with Arrow data for your column-oriented handling. And nowadays, the primary thing you're going to be doing is you're going to be shoving that in the data frames, which are column-oriented. And so you avoid copies and transposes on both sides, and everything becomes massively faster. As I said, it's specification. You have the zero copy data movement from the Arrow C interface. You make ABI compatible releases, and we have a bunch of drivers currently already open source. There's Snowflake, DuckDB implements the interface, BigQuery, Postgres, SQLite all have open source ADBC drivers that you can go see. And the whole thing is versioned, and we have bindings in a large number of languages already. And at its core, it's a header file. It's a C interface. It fits in terms of when you're dealing with, it's a vendor neutral API, it's column oriented, and if your system already returns Arrow, like say Snowflake or BigQuery already do, then it is a significant performance improvement. Now, if you're familiar with Flight SQL, you might be wondering, like, what's the difference here? Where does ADBC complement Flight SQL? And the point is that it is the client-side API as opposed to the Flight SQL being the protocol. And just to give a quick example of the performance benefits we're seeing here, DuckDB implements the ADBC interface. They benchmarked their ODBC driver versus their ADBC interface. Now, remember, local database, which means there's no network, collaboration here. There's no network traffic that's, confounding this benchmark. That difference in time here is purely the difference of that copy and convert. So if you want more information, go see the docs, check out my book. The second edition has a whole chapter on ADBC. Check out, everything for Columnar. We're building out ADBC drivers and building out new connectors for everything that we can to improve performance everywhere that needs to do connectivities to databases. So, wow, I managed.
You did it. I think you did it.
Whew. I have never done that talk that fast.
It was excellent, and I'm sure folks would have tons of questions had we had time for those questions. But Matt, thank you very much for sticking with us. I am very excited to be reading your book, too.
Thank you.
And I already saw it on your LinkedIn when I was researching. I was like, I think I want this is exactly the kind of book that I want to read. So, Matt, thanks again.